Here is an explanation for the answer to final exam question number 61 in Electronics Demystified, 2nd edition. If you have the printed book, please refer to page 429 at the bottom. We're asked here about oscillators and which one would offer the best frequency stability at 10 megahertz. Then we're given 5 choices. We can rule out choices D and E right away, the Hartley and the Clapp. Those are variable frequency oscillators controlled by inductances and capacitances, and they are not known for their stability at all. The Pierce and the Reinhardts are crystal-controlled oscillators which are known for their stability, and so is the phase-locked loop under most circumstances, and the phase-locked loop is what you see right here. The phase-locked loop, otherwise known as a PLL frequency synthesizer. And that is choice A, and according to this block diagram, you can see that this type of circuit locks the signal in phase and therefore to the frequency of a reference oscillator, which can be a Reinhardt's or a Pierce or some other crystal-controlled oscillator. This VCO is a voltage-controlled oscillator, and that control voltage derives from the operations of this phase comparator and programmable divider. These two things right here serve to keep the voltage-controlled oscillator circuit right on the frequency or some specific multiple of the frequency of that reference oscillator. So how do we choose between A, B, and C in this question? Well, the answer is that choice A works best because this reference oscillator right here doesn't have to be a crystal-controlled oscillator. It can also be an atomic frequency standard such as you might get from the National Institute of Standards and Technology, and you'll read about that in the tip on page 248. If you will go to the book under PLL frequency synthesizer, just before the section on audio oscillators, you'll see this tip. This reference oscillator can actually come from the National Institute of Standards and Technology shortwave radio station called WWV. Those call letters aren't specifically mentioned in this book, but it can actually come from the 10 megahertz signal controlled by atomic clocks, which are vastly more stable and accurate than crystals. So that 10 megahertz can be exceedingly accurate to within billionths and billionths of a part, and can go through this phase-locked loop circuit to directly control the frequency of the oscillator that we ultimately want to produce our output signal. So we can get an output signal right at 10 megahertz that's every bit as accurate as the one from the National Institute of Standards and Technology, and therefore vastly more accurate than any crystal oscillator can provide. So that little secret makes it possible for us to distinguish between choices A, B, and C and come to the conclusion that choice A is the answer to this question.